All right, let's take a look at the square and cube root review. All right, so number one asks us to find the inverse of f of x equals 2, x minus 3 squared plus 5. So inverse, we're looking for the inverse of our function. And the way we're going to do that is first, we're going to swap the x and y. Now f of x equals y, so don't get confused. We're just going to, that is our y. So I'm going to rewrite my equation as x equals 2y minus 3 squared plus 5. Now, when we're finding our inverse, we need to isolate, we need to solve for this y. We need to isolate this exponential expression first. So we're going to basically do reverse PEMDAS. We're going to subtract 5 from each side. And this is going to give us x minus 5 equals 2y minus 3 squared. Now we're going to divide both sides by 2 to get rid of that coefficient. Cancels out. And we have x minus 5 over 2 equals y minus 3 squared. Now that we have our exponential expression here isolated, we can get rid of this squared. And remember, we get rid of a square by taking the square root. So what we do to one side, we must do to the other side. And this gives us the square root of x minus 5 over 2 equals y minus 3. And so our last step is simply to add 3 to both sides, and we end up with y is equal to the square root of x minus 5 over 2 plus 3. And remember, that plus 3 is outside the radical. It is not in the radical, it's outside. And there we go. So we swapped the x and y, and we solved for the new y. Cool. Pause this for a second for station identification. And let's go on to number 2. So number 2 is asking us about transformations. We've got our parent function. We have f of x equals the cube root of x, and we're going to apply some transformations to it. So real quick, before we do that, let's review our transformations. So we have f of x equals plus or minus a, the third root, plus or minus b, x minus h, extend my radical, plus k. A, vertical stretch, compression or shrink. If it's a minus here, that's our reflect over the x. If we have a minus here, that's our reflect over y. Our b is our horizontal stretch or compression, and that's by 1 over b. H here is our horizontal shift, and our K here is our vertical shift. So number 2 is asking us for a reflect over the y-axis. So reflect over the y is going to be f of x equals the cube root of negative x. Then it's asking us to vertically compress by 1/2. So this is going to be f of x equals 1/2 cube root of x. So the 1/2 goes in the front. That's our a, our y inside. And then our last piece has us shifting left by 4. Yep, left 4. And that's going to be f of x equals the cube root x plus 4, which is going to give us a -4 for our h value, shifting it 4 to the left. Now, we take these three and we put them together, and we get f of x is equal to 1/2 the third root negative parentheses x plus 4, close my parentheses. And there we go. So be careful when you're doing this, because we've got that negative in front of the b here. We need to put the parentheses around the x minus h. Or you could say negative x minus 4, but this just makes it simpler to play with, because that way our h is still right here as a minus h, and we can find our h and k as our starting points very easily. All right, so that's number 2. Moving on to number 3. So number 3 has us simplifying the square root of 99x to the 5th, y to the 14th, z to the 6th, up to the 12th. 12th, yep. All right, so simplify. We want to get as much out as we can. So let's factor tree our 99. And since this is a square root 2, we're going to do it in groups of pairs. We're going to do it in pairs. So I have these 2 3s, so they'll come out as a single 3. So I can rewrite this as 3 the square root of 11 x to the 5th, y to the 14th, z to the 12th. Now, to factor these, we can simply go x, 2, 3, 4, 5, group 1 left over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups, 7 groups. So we have 7 groups there. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups. So we rewrite this, and we have 3 x squared, because we have 2 groups, y to the 7th, because we have 7 groups, z to the 6th, because we have 6 groups, square root. We've got our 11 left over, and we have this one loner x right there. And there's our solution. There's our simplified. There's our simplified radical expression. All right. Number 4. I'm going to show you the long way, but you can always do this on the calculator. We have x minus 1 is equal to the square root of x plus 5. So radical's already isolated, so we're going to square both sides to get rid of it. So this becomes x minus 1 squared equals x plus 5. Now comes the fun part. We need to expand this binomial, because remember, this is x minus 1 times x minus 1. equals x plus 5. So we're going to distribute, we're going to FOIL our x minus 1 or x minus 1. And so we get x squared, so x times x times negative 1 minus x times negative 1, so minus 2x, and then negative 1 times negative 1 plus 1 equals x plus 5. Now we need to solve, we continue to solve for x, so we need to get everything on one side and 0 on the other. So we're going to minus this x plus 5 from both sides, minus x minus 5 minus x minus 5. And we get x squared minus 3x minus 4 equals 0. Now from here, we can factor this into x minus 4, x plus 1 equals 0. So x equals 4, x equals negative 1. We're almost done. Now we need to check for extraneous solutions. So we go back to our original and we plug in a minus 1. X minus 1 is minus 2. Negative 1 plus 5 is 4, the square root of which is 2. So let's write this out. Negative 1 minus 1 equals the square root negative 1 plus 5. This is negative 2, 2, no. So this is extraneous, meaning this x minus 1 is an artifact from the solving and doesn't actually work. Check the 4. We have 4 minus 1 equals the square root of 4 plus 5. So this is 3. This is the square root of 9, which equals 3. True, valid solution. There we go. Alternatively, and probably recommended, if you split this into y1 equals x minus 1 and y2 equals the square root of x plus 5, second trace intersect. Wow, misspelled intersect, not intersect. Intersect. So not a bug, but where the two cross. And find that point. And that point will be 4. All right, so that's 4. Number 5. Number 5 says to express the 5th root of 17a to the 7th as or in exponential form. All this is saying, get rid of radical. So how are we going to do that? Well, what we have to remember is that when we have a rational exponent, we have the power over the root. So we have a 7th power and a 5th root. So this is going to be 17a to the 7th power over the 5th root. And that's it. Making sure that we have the parentheses because the 17 is affected by these two exponents, the root and the exponent. So we need to make sure the 17 is inside the parentheses being affected by the rational exponent as well. Number 6, we have negative 2 cube root x minus 5 plus 7, and it's asking us transformations. So this negative out in front, let's reflect over the x-axis. Inside, it'd be reflect over the y. Outside, reflect over the x. The 2 here, out front, it's in the A position. So vertical stretch by 2. Just keep drawing my little arrows. Bing. This -5, that's inside, that's our h, that's our minus h. So this is a horizontal. And it's going to go minus, so it's going to the right. Because our h is going to be 5. So it's shifted our starting point to the right 5. And then lastly, we have this 7, which is our vertical. And because it's positive, it's going up by 7. And that's all there is to it. Regular transformations. All right. Number 7. So we have solve 2 third root x minus 1 equals third root x plus 27. Now, you could graph this y1, y2, but it's just as easily to do this as algebraically because we've got a radical on both sides. So all we're going to do, 2 third root x minus 1 cubed third root x plus 27 cubed cancels out the root, cancels out the root. The 2, because it's in front, outside the radical, we have to cube it. So we get 8 x minus 1 equals x plus 27, which gives us 8x minus 8 equals x plus 27. Add 8 to both sides. We have 8x equals x plus 35. Subtract x from both sides. We get 7x equals 35. X equals 5. And there we go. And that's it. And we can plug it back in if we wanted to check, and it does work. Because that becomes 32. We can pull out an 8, which would be our 2. That would leave us with a 4. And here this would be 5 minus 1, which is a 4 with a 2 out front. Equivalent expressions. All right. Number 8. Number 8, first of our word problems. We have a formula, V equals AR to the 1/2. All we have to do is plug and play. So we read this and it gives us A is acceleration, max acceleration is 32.9. So A equals 39.2, sorry. V equals 14, R equals question mark. So now we're just going to plug these in. And we have 14 is equal to 39.2 R to the 1/2. Now remember, 1/2, we have power over root. So this is raised to the first power, the second root, aka square root. So to get rid of this, we're going to square both sides. 2 times 1/2 is 1, cancels out. 14 squared, we have 196 is equal to 39.2 R. Divide both sides by 39.2. And we get R equals 5 meters. So 5 meters is the smallest radius any curve on the car can have. Otherwise, its velocity gets too high, car comes off the tracks, no bueno. So we have our little roller coaster action going. Anything smaller than 5, crash. All right. Number 9, range. So we have g of x is equal to the square root of 3x minus 5. So if we look at this, what's our starting point? Our starting point, we have no h underneath here. So our h is 0. And we have this minus 5. So there's our starting point. We have no reflections. No reflections. So without even, I can go, this is 0, this is 5. This is going to look something like that. Because we have no reflections and we have a starting point of 0, 5. Or 0, negative 5. Oops, sorry. So that's actually down there. So, domain. What's the value of our first point on our graph? 0. And then it goes on forever towards infinity. So infinity. Likewise, our range. What's our minimum y value? Minimum y value. Y equals negative 5 right there. And then it goes up. So negative 5 to infinity. And there's our domain and range. Ten. We have the formula. D is equal to the third root of 5w over 0.03261, where d is equal to our diameter and c is equal to carats, not carat. Okay. So again, we're told that we have an average diameter. So D equals 8 millimeters. And we're asked to find W. So W equals question mark. So again, we're just going to plug and play. So 8 is equal to the third root of 5w over 0.03261. We're going to cube both sides to get rid of this cube root. And so we have 512 is equal to 5w over 0.03261. So if we divide 512 or to multiply both sides by this 0.03261, we get 16.69632 equals 5W. So we're going to divide by 5. And we get 3.339264 equals W, but it says nearest tenth. So, whoops, that's a W. So 3.3 carats is the weight. Whoops, it's weight. W equals carats. Oopsies. All right. Number 11. Number 11 is just asking you to compare your transformations to what they say. So we have f of x is equal to negative 5 square root of x minus 1. So first things first. The negative, again, reflect over x, because it's out front. The 5, vertical stretch by 5. Because remember, a value is whatever it is. Larger than 1, it's a stretch. And then our last piece right here, we have minus 1. So that's going to shift right by 1. Now you can compare those to what the paper says, see what's wrong or right. Now, shift right by 1, we have no k value, so our starting point is going to be 1, comma 0. So our starting point is 1, 0. So in terms of domain, 1 is our minimum value. So our domain, 1 to infinity. Pause. All right. Number 12. So we have a car. And this car is going 75 miles an hour. And its skid is 300 feet. And it's asking us for the coefficient of friction. And it's giving us the formula: speed is equal to the square root of 30 times distance times coefficient of friction. So all we're going to do again, plug and play. We've got a speed, we've got 75 miles an hour. We've got this equal to 30 times our 300 feet times our coefficient of friction, or F. So this is 75 is equal to the square root 30 times 300, 9,000 F. Now we need to get rid of our radical, get rid of our square root. We're going to square. And so we have 75 is equal to, 75 squared is equal to 9,000 F. So 5625 is equal to 9,000 F. Divide by 9,000. And we get F is equal to 0.625. So there's our coefficient of friction. for this surface. All right, 13. We have f of x is equal to the third root of negative parentheses x minus 3 plus 1. And it's asking for the intercepts. So what we're going to do, handy dandy calculator, we're going to go to y equals. We're going to clear, we're going to clear. And we're going to go right here, and we're going to go, so this is back. Okay. So math 4 to get our cube root. Negative key, make sure you're hitting the negative key, not the minus key for that one. Parentheses, x minus 3, parentheses. So you see how the negative is smaller than the minus? That's how you can kind of tell them apart visually. Cursor out, plus 1. We're going to go to our graph. Zoom. Let's go back. Here, zoom. 5. Zoom. What'd you do? 6. There we go. So there's our action going on. There's crossing the x, there's crossing the y-axis, there's crossing the x-axis, so we don't have to adjust our window. To find the y, we're simply going to go second table. And at 0, we're 2.4422. So our y-intercept is equal to 2.4422. Now, for our x-intercept, if we go back to y equals, we go to y2. We put in a 0. This is our x-axis. And we go second trace 5 for intersect. And now we can just hit enter 3 times. 1, 2, 3. And there's our 0. There's our x-intercept. X equals 4. And we're done. Okay. On to 14. Solve. So solve 2 cube root x minus 5 equals cube root 6x. So cube root, we're just going to cube both sides. So we have 8x minus 5 equals 6x. Distribute our 8. 8x minus 40 equals 6x. Subtract 6x from both sides. And we have 2x minus 40 equals 0. Add 40 to both sides. And we have 2x equals 40. X equals 20. And there's our solution. Okay, 15. We have f of x is equal to 2x plus 8 squared plus 3 with a domain restriction -4 to infinity. All right. So a couple of ways we could find out, and it's asking us for domain of f of x. Or the inverse. Now, easiest way is what's the range of this? So we rewrite our f of x, and we factor out that 2 inside. So that becomes a b value. And so we have x minus h plus 3. So this tells me that my vertex -4, 3, which makes sense because -4 right here. 3 is what we're looking for. This is our k value. Plus 3. So this is telling me vertical parabola opening up. So 3 is minimum y value. So if we graphed this, we'd have about a -4, about a 3, and it would look like that. So the range of f of x equals 3 to infinity. Therefore, therefore, the domain of the inverse equals 3 to infinity. Ta-da. Oops. Let's leave that up there for a second. Okay. All right. 16. So we have solve 3x to the 4 thirds, 3/4 equals 1029. Two ways to do this. Two ways. First way, we're going to divide both sides by 3. And so we have x to the 3/4 equals 343. And then from here, remember, this is x power over root. From here, we could take the cube root of both sides. Which gives us 343 cubed root should be 7. Yeah. So this gives us x to the 1/4 is equal to 7. Now we raise both sides to the 4th, and we get x equals 2401. So that's one way to do it. The other way to do it, since we have x to the 3/4, we can raise that to the power of 4/3. So this just cancels out. And we have 343. Hit the caret key. 4 divided by 3. 2401. So either way works. So 17. We have our table. We have x, comma, y. -3, -2, 1, 0, 6, 1, 13, 2. And we have our equations. We have y equals negative x minus 3 plus 2. We have y equals square root of x plus 3 minus 2. We have y equals square root of x minus 3. And we have y equals the square root of 3 minus x plus 2. Now, looking at these, this first one has this minus, so it's going to reflect over x-axis, meaning y values decrease. Not it, because the y values are going up. This third one and the fourth one, y cannot be negative. Y cannot be negative. Because there's no way, a square root has to be either 0 or positive, plus 2. So there's no way for y to be a negative 2. There's no way for y to be a negative 2. That leaves, that leaves this one. Alternatively, we look at this, and we have y is equal to h and k, square root of x minus h plus k. Y is equal to the square root of x plus 3 minus 2, which is that one. Either way works. All right, 18. Solve 4x minus 2 to the 4 thirds minus 5 equals 304. Just like the earlier ones, we need to get this expression by itself. So we're going to add 5 to both sides, and that gives me 4x minus 2 to the 4 thirds equals 309. Divide both sides by 4. And that's going to give us x minus 2 to the 4 thirds equals 77.25. Now, we're going to raise both powers by the reciprocal. So we're going to take this x minus 2 to the 4 thirds and raise it to the 3 fourths. And we're going to do the same thing over here, 77.25 to the 3 fourths. And we get x minus 2 is equal to 26.057-ish. So x equals 28.057. Right there. All right. Last one, 19. All right, take 3 on number 19. So we have our graph. We have our starting point here at 0, 2. And we're going this way. And this is f of x is equal to 2 square root of x plus 2. So first is write f negative 1 of x. So f negative 1 of x, the inverse of x. We're going to swap our x and y, so this is going to become x equals 2 square root of y plus 2. We're going to minus 2 from both sides. We have x minus 2 equals 2 square root of y. Divide both sides by 2. This gives us x minus 2. And to make things simple for us, I'm going to times this by a half. Same thing. Equals the square root of y. Square both sides. And so now I have y is equal to 1/2 x minus 2 squared. And there's my parabola. Now if I look, my h and k, I have 2 comma 0, which makes sense because that's the inverse, or that's the swap in the x and y. And so then this is going to go this way. So if we look, that's our vertex. So the domain of f negative 1 of x is going to be 2 to infinity, restricted so that it's the range of this one. And our range of the inverse is going to be our lowest y value, 0, because that's our vertex, 0 to infinity. And there we go. And now we're done. Ta-da!